like to do is I'm going to find r. Because remember, we're trying to convert this to, I want to put it under r comma theta. That's what we're trying to do. Let me erase that a little bit. Okay. So to find r, what I want you to remember is that x, erase. If you go back to, I don't remember what page it was on. Don't let me lie to you. I guess the page before, it tells you that x squared plus y squared equals r squared. So x squared plus y squared equals r squared. So do you agree that that would be 8 plus 8 equals r squared, which means that r squared equals 16 and r equals 4. So I know that my r value is 4. Ask me a question. No? Okay, I'll ask a question. Dr. Crucili, what? I thought if you took the square root that it could be plus or minus 4. And we know that it is possible to have a negative radius because we were plotting points yesterday and we were plotting a negative radius. So how do I know that my r is positive in this situation? Great question.
Because the quadrant?
Yes, exactly.
That it is in.
Yeah, until we find theta and we prove otherwise. Right now, I know that this point is in quadrant 1. Do we agree with that? That point's in quadrant 1. So I'm right now, I'll fix it later if I need to. But right now, I'm assuming that this is going to be all positive. Okay. So then the second thing that you're going to do is you're going to find theta. You're going to find her. Yep, I'm waiting. Go ahead. Oh, it's okay. No, it's okay. It's okay. Sometimes you have to say it out loud and then you catch it. So it's fine. Okay, so we're good? All right, moving right along. So we're going to find theta. That's your second step. To find theta, you're going to take the tangent inverse of y over x, and that is going to equal theta. Okay? So if I do that, wouldn't I get the tangent inverse of the square root of 8 over the square root of 8? That's going to equal theta. And so this is tangent inverse of 1 equals theta. And where does tangent inverse equal 1? Anybody? Where does tangent inverse equal 1? Getting some.
Yeah, pi fourths. You got it.
Yep, Jude got it. Thanks, Jude. Yep, pi fourths. So theta is equal to pi fourths. And that is the answer. Are we okay? Does anybody have any questions or concerns? My favorite daughter is walking in with a fresh cup of coffee for me. So
I'm your own daughter. I've been over this. I'm your only daughter, but hi.
Did you hear her? She's like, I'm her only daughter, but hi. That's why she's my favorite. Okay, are we okay? Any questions on this? Okay, I want you to try B. Or ask me a question about this and then try B. And then we'll meet up. Oh my gosh. With the first one? Okay, it's okay. Go ahead. Okay. How are we supposed to? Right. Well, you shouldn't have any. Okay, y'all ready? Okay. Oh, yeah. Okay, here we go. Step 1. Anybody find R?
2 square root of 2.
Yep. Is everybody okay that R is 2 square root of 2? Is that okay?
Is that okay? You got the same respect on his base as the old man, so.
Hold on. I think.
He's only 14 years old, JR.
Okay. Sorry. Just muted people. All right, so here we go. So is everybody okay with this? You would have 6 plus 2 equals R squared, because I squared both of them. And so then R squared equals 8. And so then R equals 2 the square root of 2. Everybody okay with that? Any questions? Okay, now what about theta? I don't hear anything about that. So you should have did tangent inverse. Do you agree with that? Of the square root of 1/3, which is tangent inverse the square root of 3/3. Do we agree with that? Okay. No. It's okay. What are we thinking about?
It's close.
It's close. Anybody know?
I'm gonna let her get this one.
Because that's what the square root of 1/3 is. Okay, hold on. Did you have negative square root of 2 over negative square root of 6? Isn't that the square root of 2 over the square root of 6? There's a rule that says if you have a radical on top and bottom, you could just put the whole thing under the radical. That did it come out pretty? You have a Casio? I don't. And also, you don't want to rely on things like that because you're getting the wrong answer. Did it come out as 30 or negative 30? Oh, no, it came out as 30. It came out as 30. No, you're right. It did. Why is that wrong, though? No, doesn't matter whether you're in radians or degrees. Why is your answer wrong? No, something you're not thinking about. Remember, I told you yesterday, I was like, if you come back and you say, my calculator's giving me 30 degrees and I'm not sure why, remember? What am I going to reply back with? You don't know what quadrant we're in. What quadrant are we in? And it's not pi thirds, it's pi sixths. What quadrant are we in? We're in the third quadrant. So if you come over here, if you're in the third quadrant and this is pi over 6, then what is theta? No, that's not how far I traveled. I traveled way farther than 30 degrees. No. Look at my picture. How far did I travel? Okay, what is that? Yes, and that is the answer. So your r is 2 the square root of 2, and your angle is 7 pi over 6. Is that okay? Because you're using your calculator, and when you're using your calculator and you put tangent inverse in your calculator, what are the only two quadrants your calculator is going to look in? Quadrants 1 and quadrants 4. That's the only place your calculator will look. It's up to you to remember what quadrant you're in. All your calculator is going to do is give you reference angles. That's all it's going to do. So the pi 6 is what you got, the 30 degrees or the pi 6, that's the reference angle. And then you have to figure out what quadrant you're in. That make sense? Okay, so that's the answer. Okay, so let's try it again. We're going to try it again. Or think of a direct question for that one. Let's do C, because C is going to be a little bit harder, and you're going to tell me why. Okay? C says 3, 4. Okay? C says 3, 4. So I want you to change this into polar. Yeah. So is everybody okay that R is 5? We're good with that? Okay. What about the angle? What's the issue with the angle?
It's not on the unit circle.
Yes, it's not on the unit circle. Good job. It's not on the unit circle. So we're going to have to use our calculator. Okay. So I'm going to explain a couple of things to you on this one. So you want to make sure that you understand. Okay. Someone put it in their calculator and tell me what you get. So you're going to get tangent inverse of 4 over 3. And I want you to give it to me to 3 decimal places.
53.130.
Oh, we're in degrees? Okay. 53. let's say they were radians. Go to radians. Okay, 927. Okay. It's okay. 927 is fine. Okay, so we have that. Now, what quadrant are we in?
One.
Okay. So watch this, you guys. If it says exact answer, because let's say that I don't see anywhere in here where it tells me to round. If it tells you to round, then you're fine. But if it says exact answer, you know that you're in quadrant 1. When you put this in your calculator, it gave you something in quadrant 1. So how you would put in your answer is 5, comma, tangent inverse of 4/3. Close, close. That's your answer. Like, that's what you would type into WebAssign. Does that make sense? Because it doesn't want a decimal. So if it doesn't say to round, you're actually going to type that in. Okay? Is everybody okay with that? Which is go ahead. Because that's your R. Remember, polar is R comma theta. So your R was 5 and your theta, this is your theta. It gives you your angle, but if it says exact answer, then it doesn't want you to change it into a decimal. It just wants you to put the angle in. So you would just do tangent inverse of 4/3. Is everybody okay with that? Because I'm going to blow your mind on the next one. We okay? Okay, I'm adding 1. I'm going to add 1. So even though this is not here, please add it to your notes. What if I had 1, comma, -4? I can add as many as you want to until we get this. I can add another one after this if you want me to. 1, comma, -4. Let's say that I have this one, and I want you to find it in polar form. So this is X and this is Y. This one's a little bit different. So that's why I want to make sure that I do a couple of examples so that you understand. So find, because it looks like everybody's able to find R okay. Anybody find R yet? Okay, so R is the square root of 17. Okay, if you have any questions about how she found R, please let me know because you don't want to miss that. The hard part should be the angle. Okay, so let's say that I told you not to round. You are not allowed to round. Okay, so then what is the exact angle? Well, oh man, I'm upset. Why am I upset? Because this is part 2. This was part 1. Part 2 is us finding the angle. I'm going to do tangent inverse of -4/1. Does everybody agree with that? -4/1. And if you put it in your calculator, you're going to get an answer, right? You're going to get a negative answer. Is that okay? So then what is the answer? Your R is going to be, put it down here. Your R is the square root of 17, but what am I going to put in for the angle? What do I put here if I'm not allowing you to round? Nope. This is hard. I'm going to explain it to you. Okay? Everybody listen. If you put tangent inverse of -4 in your calculator, what do you get? Try it in degrees. Try it in degrees. Maybe you'll understand it better. Make sure your calculator's in degree mode. This is going to be in radians because if you look at the instructions, how do I know that I'm in radians? If you look at the instructions for example 4, it says where R is greater than 0. So that means that all of our radiuses are going to be positive. And then it says that your angle has to be between 0 and 2 pi. So we're in radians. not only are we in radians, but we have to be between 0 and 2 pi. Do y'all see that? So I know that I'm in radians, but maybe you'll understand it better if you're in degrees. So if you put tangent inverse of -4, what do you get? Okay, so not -76 degrees. If you were to come over here and you were to do -76 degrees, what quadrant are you in? You're in quadrant 4, but you went this way. Yes, you went -76 degrees, but you went this way. Your calculator, when it's doing tangent inverse, only knows how to go up and down to quadrant 1 and quadrant 4. That's it. But then the instructions say that you have to be between 0 and 2 pi. So you're not allowed to go this way. So then do you agree that you want to go this way? Does that make sense? Okay, but I need exact answers. You're approximating. Do you agree? Because it's a decimal, isn't it? So what you're doing is, aren't you taking tangent inverse of -4 and adding 2 pi to it? Didn't you take what you said, this angle, and you added 2 pi to it so that you would go the other way? We made a complete circle. And this would be your answer. You want me to do one more? Are there any questions?
This might be kind of a
2 pi minus 2 pi minus. Yeah, I think it'd be okay. I just kind of did it from where the angle was, but I guess that's the same thing. 2 pi minus that. 2 pi minus that. You would get a negative answer, would be plus. I don't think. Mood. But I don't think that's the same thing. But it's not the same angle. Yeah. Oh, maybe it is. I don't know. Hold on. 2 pi minus tangent inverse of -4, right? And 2 pi plus tangent inverse. You get two different answers. They're two different angles. 2 pi minus, if you put 2 pi minus tangent inverse of -4 and you put 2 pi plus tangent inverse of -4, they're two different numbers, is what I'm saying. So you have to do that plus 2 pi. Okay. I'm making up another one. I'm just making this one up.
Jude made a good point in the notes, Dr. Cruz.
Yes. Hold on. 2 pi minus 10. Oh yeah. Well, that's true too. But that's not the answer. Jude, I think are you talking to Melissa? Melissa, 2 pi minus tangent inverse of -4 is bigger than 2 pi. Yeah, that's what I was saying. They're not the same thing. So that's why the answer is 2 pi plus tangent inverse of -4. And that is below 2 pi. Okay, so try this one.
Dr. Cruz, can I ask you something real quick about this too?
Sure.
Could you just, I mean, I kind of did it in the calculator and it's making sense, but maybe you can help me. I just rearranged it to be 4 tangent of 1. That's illegal though, right?
What? What did you do?
Because it's not, never mind, because it's not set. See, all you gotta do is talk it out loud and I get it now. It's not
Okay.
set equal to 0, so I was doing all kinds of illegal stuff.
Okay. So let's say that I said that this right here was your rectangular point. And I want you to change it into a polar point. And I want your final answer to be in radians and exact, which means you are not allowed to use decimals. So go ahead. Okay, ready? What's R? Does that reduce?
2 square root 13.
36 plus 16, right? Oh, excuse me, I burped. What did you say it was? 2 square root of what?
13.
Is everybody okay with that? So we're cool on the R's, right? Anybody try to work the theta out? So you did tangent inverse? You did tangent inverse of 2/3? Ooh, it's 2/3. Okay, I'm cool with that. And so as that part, and so when you come over here and put your answer, you would have 2 the square root of 13, comma what? No. Nope. Uh-uh. Copy paste. What do I put there for the angle? I'm cool with your R. What is theta? Nope. Tangent exists everywhere. If you make them both negative, they're positive. It's positive. Nobody has any ideas? What's the answer? I'm telling you right now, if you send me this question on your homework, I'm just going to reply back with the same thing every single time. Okay. Answer my questions.
Would you add a pi to it?
Yes.
Because when you type it out into the calculator, you should end up in the first quadrant. But we're in the third quadrant.
Yep. That is exactly correct. This is your answer. That's correct. Okay. If you were to give this to me without anything else, if you were just to tell me this, what quadrant are you in? You're in quadrant 1. How do I know? Because that's positive. And you're dealing with inverse. And tangent inverse only exists in 2 quadrants, quadrants 1 and quadrants 4. That's the only place your calculator would look. So since that's positive, it's saying, hey, your calculator thinks you're in quadrant 1, but you're not in quadrant 1. Both of your values are negative. You're really over here. So how do I get from over here to over here? You have to add 180 degrees. You have to add a pi. So I'm going to take where you are in the first quadrant, because I agree, this is going to give you something in quadrant 1. But you're going to have to add pi because you're not supposed to be in quadrant 1. You're supposed to be in quadrant 3. So that's why you had to add a pi. So if you come back over here, I'm just going to I'll go back up. Here, right, when you put tangent inverse of -4, hey, that's negative. And you're using inverse. So your calculator thinks you're in quadrant 4. Well, guess what? You are in quadrant 4. The problem is that when you use tangent inverse, it's going to go down to get there. It's going to go this way. But your instructions said that you have to be between 0 and 2 pi. So you can't have a negative angle. So even though I am where I'm supposed to be, I went the wrong way to get there. So I'm going to start where I'm supposed to be and do a full circle. And I would end up back this way using a positive angle, which is why I took where I was in quadrant 4, but I had to add 2 pi in order to get back there the right way. Is this kind of making sense? You have to think about this one. If you look at this one, you were in quadrant 1. If you were just to put this, if you were to show me this, I would say, okay, you're in quadrant 1 because this is positive. You're using inverse, so I only can use quadrant 1, okay? And I went up to get there. Cool, because that's where I was to begin with. So you didn't have to add anything to that because you were already in quadrant 1. You already were where you were supposed to be. And this angle is in between 0 and 2 pi. So you were fine. So you have to decide when you get these on your homework, am I where am I supposed to be? How do I fix it to get there? What quadrant am I supposed to be in? You have to think about these things in order to give me the right answer. Okay? Anybody have any questions? Okay, moving on. Example 5. So, in example 5, it wants me to convert an entire equation into polar form. So we have x squared plus y squared equals 9. Now, some of us might be thinking to ourselves, I don't understand. Like, why do we even need to be in polar form? Like, I don't get it. Why can't we stay in rectangular form? It's what I'm used to. It's what I know. Like, what is the deal? Why are we even doing this? Does anybody know what this graph is? X squared plus y squared equals 9? Does anybody remember from geometry in high school? Oh, don't worry. We're going to go over it again in the last chapter. But does anybody remember off the top of their head? Okay, so let me ask you another question. If I wanted to put this in my calculator so that I could graph it, how many of y'all have y'all's calculators? You need those today for sure. You need them today, so grab them. If I wanted to put this in my calculator to graph it, what would I have to do first?
Get everything to one side.
Yeah, you would have to isolate y. So you would get y squared equals 9 minus x squared. You don't have to do this if you don't want to. I'm just proving a point. And then you would have y equals plus or minus the square root of 9 minus x squared. Your calculator doesn't have a plus or minus button. So you're going to have to do this. So you're going to go put that in y1 and that in y2, and you're going to graph it. So someone do that. In your calculator, go to y1, type in the square root of 9 minus x squared, and in y2, put in negative square root of 9 minus x squared. Make sure the negative's on the outside. Make sure the 9 minus x squared is on the inside. I'll give you a minute. I'm literally timing you.
You get 2 half circles.
Yeah, you should. You should get like a that, like a circle. Do you agree? This is a circle. Yeah, this is a circle with a radius of 3. Is everybody okay with that? Okay, so now what I'm going to do, and that took a while. It took me a minute to like, you know, to do this. Does it make sense? It took me a minute to do that. To get y by itself, to plug it in my calculator. This took a whole minute. Now watch this. Side notes. I'm putting it here, but we've already talked about this. There's a couple of things. The first thing I want to put for the side note is that x squared plus y squared equals r squared. We know that. We also know that x equals r cosine theta, y equals r sine theta. I'm just writing down what is on the pages before. If you go back to page 104, all of these equations are on there. I'm just bringing them to this page so you can easily reference them. But everything that I just wrote down is on page 104. Okay? So if I wanted to change this into polar form, do you agree that x squared plus y squared equals r squared? Is everybody okay with that? And if I were to take the square root of this, do you agree that I would get r equals 3? Plus or minus, but do you agree r equals 3? Right? Okay, so listen to me very closely. If you have a TI calculator, you need to go to mode, which is right next to your second button, mode. And about 4 options down, you should see function, par, pol, sequence. You need to choose pol, P-O-L. Double enter to change it, and then hit y equals. Casio's, I have no idea. How do you change your mode? Someone, if you figure it out, say it out loud. How do you go from radians to degrees? Where do you go? I need help today. I need communication. Yeah. Yes. Yes. Perfect. Thank you. So go to graph and your type, and you want R equals for Casio's. For TIs, it's mode, and you have to change it to pol, P-O-L. Is everybody okay with that? So now what I want you to do is in polar mode, for the first one, I want you to put R1 equals 3. R1 equals 3. Graph it. Let me know what you see. You might have to zoom 6 it. Or
A
standard.
full circle.
It's a circle. It's the same thing. Except that we could see it. I didn't have to square root anything. I don't have to put things in multiple places. I just put R equals 3, and it's going to graph me a circle with a radius of 3. Everybody okay? Any questions? So your goal, you guys, you're going from rectangular to polar. You're trying to get rid of the X and Y's, and you're using basically these rules in order to convert. So, for example, let's say that I had Y equals X squared, and I want to get this into polar form. Is that okay? Now, remember, in order to put it into polar form in your calculator, even in this calculator, it's R equals, and you type in whatever you want to type in, okay? So keep that in mind. So if I were to do that, looking over here with what I know, my very important box over here, do you agree that Y is equal to R sine of theta? Do you agree that X is equal to R cosine theta? I'm stopping. All I did was replace Y with R sine theta. X is R cosine theta, but this is X squared, so I have to square them. Is that okay? Yes, no, maybe? Okay. I'm trying to get R by itself. Like I want just one R. So I'm going to divide both sides by R. There's an R on both sides. And I get... Is that okay? Oh, wait. The square's still there. Nobody stopped me. Okay, to get R by itself now, I have... Sine should be on. Nobody's stopping me. I'm making mistakes and nobody's stopping me. Are we okay? Can y'all hear me?
Yeah, I was trying to figure out what you were doing.
I'm trying to get R by itself and I failed miserably. That's better. And there's my answer. I'm stopping. I guess y'all are still writing. So I started with Y equals X squared, and it wants me to change this into polar, which means I can't have Y's and X's anymore. I can only have R's and thetas. So I changed Y into R sine theta, and I changed this to R cosine theta squared. Is everybody okay at this point? Any questions there?
Yes.
Now, in order to... No questions. Okay. In order to put it in your calculator, R has to be by itself, right? If I wanted to actually graph this in a calculator. So that's my goal, is to get R by itself. Well, I noticed that there's an R here and there's two R's over here. So there's an R here and two R's over here. So I divided both sides by R. So that gives me sine of theta on the left and R cosine squared of theta on the right. Is everybody okay with this part? Because I'm trying to solve for one R. Now, here's my R. I'm trying to get R by itself. So I divided both sides by cosine squared theta. So then I get this. Then I split this fraction into 1 over cosine theta times sine over cosine. These are the same thing. And we know that 1 over cosine is secant, and we know that sine over cosine is tangent. And there you go. You have r by itself. R is equal to secant theta, tangent theta. R is by itself, and it looks clean. Are we okay? Any questions? Okay, let's go the other way. Let's say
Okay, I do have a question. I apologize.
hold on. I
For
forgot what-
alpha,
hold on. For A?
yeah,
No,
Yeah.
you don't. So basically, all we're
but
doing.
it's the
This is A.
so the polar form is the square root of 9 minus x squared, and the
Nope.
minus square root of.
There should be no X's and Y's.
Ah, gotcha. Okay.
Rectangular. This is polar. R's
Okay,
by-
I was.
gonna say there.
That's what I
but
thought,
basically,
but
what would you
then we looked at the
if
graph,
they
and I
didn't
got
have
a
to use
little bit
100%,
confused.
and it turned out to be
We
more
okay now?
than what you sent it,
Yeah,
it would be
yeah.
just fine.
So now what we're going to do is we're going to go the other way. So let's say for A, we're on example 6. A, R is equal to 2 cosecant theta. And I want to change this into rectangular. So I want to go from R's and thetas back to X's and Y's. And you only know that box that I highlighted. That's all you know. Where's that box that I highlighted? I forgot already. I keep losing my pages. Okay, here we go. You only know that. What's in the box? Is that okay? These are the only relationships that you know. So keeping that in mind, give me some ideas. How can we change this back to X and Y's?
Could make cosecant sine,
Sure, how?
2 over sine.
You said something about the R is not X squared plus Y squared, right? Oh, I'm sorry. Oh, okay, sure. Yeah, you could do that. There's two ways of doing it. So you're saying that X squared plus Y squared equals 4 cosecant squared theta. Right? Yeah, that's and this so this is what you would get, right? So this is what you have over here. So you have X's and Y's, but you still have a theta. How are we going to get rid of that? You see what I mean? You can't be all in polar. You either have to be all in polar or all in rectangular. So all in terms of X and Y or all in terms of R and theta. We get it? So I like this approach right now. So what can we do now? I don't like fractions. So what could you do here?
But the 2 on the other side,
Not the 2. The 2's
or
fine.
the sine, just multiply the sine.
Multiply both sides by sine. So you get r sine of theta equals 2. Do you agree with that? I just multiply both sides by sine. What does r sine of theta equal? Anybody looking at the box? Done. If you go back to the box, r sine of theta equals y. So I replace the r sine of theta with y, and you get y equals 2. There's no thetas, no r's. You're done. That's the answer. Okay. Okay, let's do B. B says R equals 4 over 1 plus 2 sine theta. So I'm trying to get you to have like a checklist. The first thing is I hate the fact that this is a fraction. So I'm going to make it not 1. I just don't want there to be fractions. So I'm going to multiply both sides by the denominator. Is everybody okay with that? And remember, we're trying to get this in terms of x and y. So let me distribute this, and I would get r plus 2r sine theta equals 4. I distributed the r. Now, this comes with practice, but why did I distribute the r? Does anybody see anything that I can convert right now? Anybody see anything I can convert? What does r sine theta equal?
The 2r sine. Oh, so you can go ahead and turn that into a y, then solve for y.
But that's fine. You could totally solve for y. The problem is this r is still in there, and we have to get rid of it. I didn't even try it your way. We can try it your way. So you could have 2y equals 4 minus r. Do you agree with that? But what am I going to turn r into?
I have no idea.
So what she's doing is anytime you have a short-term distance.
Okay, so what is the only relationship you know with r? We don't have an r sine theta. We don't have an r cosine theta. Do you agree with that?
We know you can square it.
Oh, you can. So do you agree that r right now, what did I do? I didn't do this stuff. So let me show you what I did. I mean, like, I don't see anything wrong with it. I feel like it's going to get messy. I did this. I moved the 2y over. Ooh, I don't know what I just did. Okay. I moved the 2y over, and I got r equals 4 minus 2y. And then I did that. I squared both sides. So I took this side, and I squared it, and I took this side, and I squared it. When you square it, you get r squared equals, what do you get? 16 minus 4y plus 4y squared. And since this is not linear, it's not linear, I'm just going to go ahead and move everything over to one side. Because when you solve something, you want to set it equal to 0. So I would have x squared plus y squared, right? Nope. X squared minus 3y squared plus 4y minus 16 equals 0. And there's my answer. Any questions? Yes, no, maybe. This takes practice, and it takes manipulating some stuff and trying to get it by itself, but you really want to make sure that you remember this box. And it's okay for you to try something. Like, we tried something over here, and then I didn't know where to go. I didn't know what to do. So then I came back and was like, is there anything that we can do here? So it's okay to try stuff, just like you did with proofs, right? To try to do it by itself. But think about the box and what you know, and then how you can manipulate this in order to be all x's and y's. Okay? Okay. Section 8.2 We're going to start section A2. We won't we're obviously not going to finish it, but I do want to go over one thing so that tomorrow it'll go a little bit quicker, okay? On section A2, the top part we've already learned. We've already talked about the top part where you have points for a rectangular plane on the left and then points for a polar plane on the right. We're okay with that. On example 1, it wants you to sketch. On example 1, it wants you to sketch as a typo. It should say r equals 2 sine theta. It says 3 sine theta. That's a typo, so fix that. And then it comes over here and it gives you a coordinate plane. And it wants you to graph those points. And I taught y'all how to graph already, right? You'd go to your radius, like 0, 0. And then you would go to 1, your radius of 1, but go up to pi 6. And then a radius of 2, the square root of 2. A radius of square root of 2. And then go up to square root of 2, pi 4ths. And so then you'll start to get like this picture. So you can, I taught you how to graph points already, so you could probably do that one. It's the bottom part that's new. Okay, we are going to start looking at polar graphs and testing for symmetry. Okay, so this is the part I want to go over before tomorrow when we actually start working out problems. Do y'all remember how to test for symmetry? We've actually covered it in this class. What does it mean for a function to be even, and what does it mean for a function to be odd? Do y'all remember that? Okay. 1-to-1 had to deal with inverses, but like graphically, what would happen if a function was even or odd? Not necessarily. Yeah, okay. That's better. Which axes? With what? For which one did y go with? Do you remember? No. Yes, cosine is even because it's symmetric about the y-axis. So if you're even, that means you're symmetric about the y-axis. Symmetric about the y-axis. And then if you were odd, does anybody remember what it meant to be odd? Symmetric about the origin. This is college algebra, and we discussed it in this class. Does anybody remember how to test for symmetry? No, that's inverses. That's not even and odd. How do you test for symmetry algebraically? Yes, good job, Jefferson. It's even if you substituted negative x in and it came back out exactly the same. It was odd if you substituted negative x in and you would get negative f of x. Everything would change signs. So this was the rule for testing symmetry when we were testing on a rectangular plane. So this is stuff that you learned in college algebra, and we did it in this class too, in the beginning of this class. So that's something to remember. So what we're going to do tomorrow is we're going to take graphs, polar graphs, and we're going to test for symmetry. Okay, so we'll do that tomorrow. I just wanted to kind of recap what you should already know going into tomorrow when it comes to symmetry and being even and odd. Okay? All right, so I will talk to y'all tomorrow. That's it for today.